Hi, and welcome to my kitchen. Today, I want to talk to you about acids and different acids that you use in your kitchen, and also what types of acids, such as vinegar or even buttermilk, you might have, but also then how you might want to measure the acidity in your kitchen and how we do that in the lab. Um, so, to explain what an acid is, we have to start with water. So, water, as you may know, is made up of two atoms of hydrogen and one atom of oxygen. And you might think that that's the end of the story. That's water, and water goes on and does water. The thing is that they don't always like to hang out together, right? So most of the time they hang out together as two hydrogen atoms and one oxygen atom, all nicely bonded. But sometimes a hydrogen atom goes rogue and breaks apart, starts to float around independently, leaving the other hydrogen atom, the oxygen atom, binded together, and those two wander around separately. Um, and under certain circumstances, you can set it up so that you add other things to it that add even more hydrogen ions to that solution, and that's when you have an acid. Alternatively, you can also have fewer hydrogen ions by again adding something to it, and that's when you have a base. So when you add, for example, citric acid to something, then you will, or acetic acid to water, then you will have extra hydrogen ions floating around, and it'll be more acidic. For example, you can add citric acid, which is from citrus fruit, or you can add acetic acid, which is what vinegar is made out of, and you'll have more hydrogen ions floating around, and then you'll have it'll be more acidic. In the kitchen, we use acids for three different effects. One is simply taste. You want a little bit of tanginess, a little bit of bite to something, you'll add an acid to it, either like using lemon juice or lime juice in a drink to make a limeade or something a little harder, or vinegar in a salad dressing to give that a little bit of bite to that. The second thing that you could use acid for is you can use it to react with baking soda. And when it reacts with baking soda is inherently a base. The acid and base come together and they give off a gas. They give off carbon dioxide gas in baking soda. And so if you want something to be a dough to be fluffy or have air pockets in it, like a quick bread, for example, or a pancake batter, you use that acid and base together to make it to give it a little bit of fluffiness to that. And then the third thing that we use acid for is when we're trying to get, in particular, proteins to curdle, right? And you do that when you want to make cheese out of something. You want to make a cheese sauce. So that's one of the challenges of a hollandaise sauce, for example, is you're actually adding acid there, the lemon juice, into the hollandaise sauce for the tartness in with the egg yolk. But egg yolk has a lot of protein in it, and if you add too much acid in there, then that protein will start to curdle, and you'll quote unquote break the hollandaise sauce. In the next portion of this video, what I'd like to do is show you how to use our test strips to measure the acidity or basisness, acidity. I'm not sure what the right word is for a solution that you have. Hi, welcome back. What I want to show you now is two things. One, I want to show you how we're going to measure, how we can measure pH, the relative acidity of something. And two, I want to show you that carbonated water is actually also acidic. I like carbonated water for the bubbles, but you have to be careful not to drink too much of it because it can peel away some of the layers on your teeth because of the acid reacts with the enamel on your teeth. So we measure acidity using a scale called the pH scale. And the pH scale measures the concentration of of hydrogen ions in the liquid. And that scale goes from 1 to 14, 1 being very acidic, having a lot of hydrogen ions, and 14 being very basic, having a significant deficit of hydrogen ions. Tap water, the city water that we drink, water in general, is in the middle of, should be right in the middle of that scale. So that should be a 7. So I'm going to measure that now. I filled this bottle with tap water, and then we're going to just take a little bit of that. And the way we measure pH is by, one of the ways to measure pH is there are these test strips, and they come in this nifty little kit with a little scale to measure them by. So I'm going to dip this paper in there, and I'm going to look for a color change. And so if I hold that up without shining too much of the light in here, and I try and match it up, and it looks like, you can't read the numbers, but it looks like it matches that color pretty well, even on the camera, and that color indicates that this has a pH of 7. So my tap water has a pH of 7. And I'm going to write that down right here. Writing a little sideways. So now I'm going to take my water, and I'm going to put it in this device here, which is a soda stream. So it's got a container of compressed carbon dioxide. And so we tighten that on there, and then we push the button to release the carbon dioxide into the water. Right? And so now it's got carbon dioxide in it, and you can tell because when I release this, you're going to see a cloud form in the top here. And then, yeah. So, and that cloud is the condensation of water vapor that has built up there that was initially in vapor, but then when I released the pressure, it suddenly cooled and it condensed. So now I've got my carbonated water. I'm going to pour a sample of that, and it's nice and fizzy. I'll use the rest of that later for a little bit of a treat. And, put my pH paper in. And now let's check the color again. And so now it's no longer that color. It's probably closer to 6, or maybe even that one is 5. So it looks like to me it's somewhere between 5 and 6. So whereas this guy was closer to 7 or maybe 8, no, closer to 7. It's certainly not 5. Yeah, it's closer to 7. So it looks like this is a 6. So I wrote my 6 backwards. There we go. Okay. Yeah, so that's how you measure pH using these test strips. Okay, and I just wanted to go over a few other things that acids that you'll find in the kitchen. So along with carbonated water. Again, we have our, just to get a sense of things, we have our tap water here, which we said has a pH of 7. Now I have 2 different types of strips here. The one I just showed you how to use that color matches, and then I have this other strip here that has 4 different bars on it, right? And it's a little bit overexposed, but it's got 4 different colors that you might be able to see there. So I've got 2 different types of test strips here. One is the one that we just used, or similar to the one that we just used, and the other one I think provides a little bit more accuracy. It's got 4 different test patches on it that you might be able to see there. And that allows you then to a larger range of pHs here. So here are the color charts, and as you can see, there's a lot more variation in the color charts. This goes not well, it goes from 1 to 14, but it's now by half pH increments, and each increment has 4 possible ways to match things up. So when we go to match up, let's say, take that top off. This is dried out a little bit. In fact, so as an example, I'm going to get my water again. And so now we can start to match this up. And again, now notice that the blue on the top strip has pretty much maxed out, but now, and the bottom 2 don't change much in this range, but that middle one now gives me something between 6.5 and 7. So so my tap water might be a little bit acidic, just a hair acidic. Sometimes that happens. And if you live in a city like I do, your water processing plant spends a lot of time testing pH on various things. So over here we have vinegar, and each of my test strips. I'm going to rotate this up, and now you can see me a little bit. Okay, sorry about that. A little bit of a camera mount issue. But in any case, so over here on the right, we've got vinegar, which the single color test strip gave me between 3 and 4. The other test strip that suggested that might be more accurate gave me a pH of about 1.5. So that's pretty acidic. That's probably about as acidic as it can get in the kitchen, and about as acidic as you want. Note that if you cook a lot with vinegar, especially if you're cooking with aluminum or cast iron pans, you're going to get some of that metal into your food. The aluminum isn't so great. The cast iron is actually fine, and in fact, some people use that as part of an iron supplement program. They cook with their cast iron pans and gets a little bit of iron into their food. Surprisingly enough, buttermilk. So buttermilk is acidic. It has a pH of 5, so it's not nearly as acidic as vinegar, but it's got a little bit of acid to it. You get a little bit of tang. You'll probably find that with yogurt too. A little bit of tang and a little bit of acid. What's interesting about that is if you use that in, say, buttermilk pancakes or a quick bread where you're using baking soda, then the baking soda and the buttermilk will react to give you the fluffiness, to give you the air pockets. Water, as we already said, has a pH of 7. And then just to give you an example, on the basic side, I dissolved some baking soda into this glass of water here, and took its measurement, and depending on which strip I use, I get a pH of between 9 and 10. So it is actually poor in in hydrogen ions. It doesn't have as many hydrogen ions as these OH ions. It has other ions built into it, and so the sodium ions are going to be floating around there, replacing the hydrogen ions, and so that's going to be what's in here, right? So again, the baking soda and so bases and acids react very quickly together to recombine the hydrogen and the OH molecules, and release carbon dioxide from that solution. So You want to be careful when you're trying to work with acids and bases at the same time, that you don't cause too violent a reaction. Okay, and this has been a little bit about acids and bases in the kitchen, and this is Cooking with a Physicist. See you next time.